All right, so here we have a few algebraic questions that we'll be looking at. So question 1 here says, using the method of completing the squares, solve the quadratic equation negative 3x squared plus 5 equals 2x for x. And this question is valued at 8 marks, so we know we have our work cut out for us. So if we're using the method of completing the squares to solve this question, at the current level, these are what we need to know. We need to know the formula for h, which is equal to b over 2a, and the formula for k, which is equal to 4ac minus b squared over 4a. Now, these formulas, they won't be on the formula sheet. So what you'll have to do is, as soon as you enter the test, you would need to write these on the paper. All right, so let's go ahead and evaluate. So now, looking at this quadratic equation, negative 3x squared plus 5 equals 2x. Now, one thing I'd recommend is to ensure that you get this equation to look like the general notation of a quadratic, which is in the form ax squared plus bx plus c equals 0. So we need to get it look something like this, where the x squared term is at the front, x term is in the middle, and the constant is by itself at the end. So we're going to be rearranging the terms here. So it's going to be negative 3x squared. We're going to bring over the 2x, so we know that's going to change sign, negative 2x and plus 5, and that's equal to 0. Now that we have this in the general form of a quadratic, we can go ahead and write what the a is. So a would be negative 3. Now the a is the coefficient of the x squared term. So the a right here is negative 3. The b would be the coefficient of the x term, so that's negative 2, and the c would be 5. So now that we have our a, b, and c, we can go ahead and calculate h and k. And we'll be doing so because in order to solve using completing the squares, we'd need to rewrite it in the form a x plus h all squared plus k. We need to rewrite it like that. All right, so let's evaluate. So h is equal to b, which is negative 2 over 2a. So that's equal to negative 2 over negative 6, which is just 1/3. So this is what h is equal to. We're going to do the same to find what k is equal to. So k is now equal to 4, a, which is negative 3, c, which is 5, minus, so always ensure you put brackets around the whatever you're going to be substituting. So that's negative 2 all squared over 4 times negative 3. So when we simplify this, we get 4 times 3, that's 20. 4 times 5, sorry, that's 20. Times negative 3, that's negative 60. And that's minus 4 over negative 12. So when we simplify this, k is going to be equal to negative 64 over negative 12, which works out to be, so that's 16 over 3. So this is what k is equal to. This is what h is equal to. So this is h and this is k. So now to rewrite them in the form a open bracket x plus h all squared plus k, we'd simply be looking at the a from right here. So this is the a that we have. So this is the a, this is the h, and this is the k. So we're going to be substituting those values here. So a is negative 3. So we have our negative 3 open bracket x. h is 1 over 3 all squared, and k is 16 over 3. So this right here that we have is the same thing as this. We just wrote it in another form. So these two things are saying the same thing. So now we're required to solve. So in order for us to solve, let's copy this. Let's go to a new page. So in order for us to solve this, we need to equate it to 0. So this is equal to 0. So now from here, the rest is basic transposition. The aim is trying to make x the subject. We want to make this the subject. And in order for us to make x the subject, we need to remove everything from around the x. So we have to start from what's furthest away from the x in terms of operation. So looking at this, the 16 over 3 is furthest away. So we're going to be transposing the 16 over 3 first. So after we transpose the 16 over 3, we're going to be left with negative 3 x plus 1 over 3 squared is equal to negative 16 over 3. So that's our first step. Next is to get rid of this negative 3. We can't get rid of this squared as yet because we have it's based on the reverse order of operations, what we can do first. So whatever we would usually do first, that's what we have to do last. So now we need to get rid of this negative 3. The negative 3 here is multiplying, so we'd have to divide by negative 3. And we have to divide over here as well. So the negative 3 will cancel. And on the left hand side, we're left with x plus 1 over 3 all squared is equal to. So when we divide by the negative 3 over on this side, let me use a different color. So it's negative 16 over 3. So we're dividing, so we know we're going to be doing the keep change flip. So this is keep change flip. So the 3 comes down to the denominator position. So now all we're doing is just multiplying across. So what we'll have in the next line is x plus 1 over 3 all squared is equal to 16 over 9. The negatives will give us back a positive. So now we need to get rid of the square root, the square, and by doing so, we can take the square root of both sides. So in doing that, the square is going to cancel. And what we'll have left on the left hand side is just x plus 1 over 3. Now on the right hand side, here is where it gets a little bit tricky. When we're solving an equation for an unknown variable and we're taking the square root, we must always use the two possible solutions. So when you take the square root of an integer, we have a negative and a positive solution. Or even well, in this case, this wouldn't be an integer. So when you take the square root of a number per se, we would get a positive and a negative result. So that would be 4 over 3. So x would be equal to, so we're going to transpose the 1 over 3. So plus or minus 4 over 3 minus 1 over 3. So to get both solutions, we're going to use a positive 4 over 3 and a negative 4 over 3. So x is equal to 4 over 3 minus 1 over 3. So this is 3 over 3, which is 1. So that would be one of the solutions for x. The next solution would be using the negative 4 over 3. So that's negative 5 over 3. So therefore, x equals negative 5 over 3 or x equals 1. So these are your two solutions for x, and that's your 8 marks. So pretty straightforward, nothing too complicated. Just be mindful of the operation here. You need to look at what you're transposing first, what you need to transpose next in order to get your solutions. Alright, so let's take a look at the next question. So this question is a system of equations where we're going to be ending up with a nonlinear or a quadratic per se. So when given a question like this, we need to look at how we can go about getting this to be one equation. And in the question, it specifically stated that we're going to be using the substitution method. We know that the substitution method involves us formulating or rearranging one of the equations to make one of the variables the subject. So we can look at both of these equations to see the complexity of these equations. And by looking at it, the first one is pretty much easy to make one of the variables the subject. So we're going to say rearrange equation 1 to make x the subject. So equation 1 would be easier for us to rearrange. So we have x minus y is equal to 5, and in order to make x a subject, we transpose the negative y. So x is equal to 5 plus y. So this would be your equation 3. So after we've made one of the variables the subject, our question is basically done. All we need to do now is to substitute that particular variable in the equation we did not modify. So this is the equation we did not modify. So this is the one we're going to be substituting where the x is. So wherever we have x, we're going to replace it with 5 plus y, because that's what x is. X is equal to 5 plus y. So now let's say substitute equation 3 in equation 2, because equation 2 is the one we did not modify. So as mentioned before, wherever we have x, we're going to be replacing it with 5 plus y. So let's use a bracket. So 5 plus y, and that's going to be multiplying y plus 3 times 5 plus y is equal to 1. So anywhere we have 5 plus y here, we could look back at the original question and realize that there was an x there, because we said that x is equal to 5 plus y. So that's where we would need to substitute the values of x. Alright, so now it's just distribution and simplification. So let's see. Y times 5, that's 5y. Y times y squared, plus 3 times 5, 15. 3 times y, 3y. Plus y is equal to 1. So after we've done all of that, the next thing for us to do now is group like terms. So the idea is to group like terms and get our simplified quadratics. So we're going to put the y squared So we have 5y, 3y, and 1y. So that's 9y. So y squared plus 9y. We have a 15 here. However, if we transpose this 1, it's going to be a negative 1. So that's plus 15 minus 1, 14. And that's equal to 0. So here we have our quadratic in the general form, and we should be able to solve this pretty easily. We could use the quadratic formula to solve it. We could use AC method, we could use completing the square. Whichever one suits you best, that's the one I would advise you to use when solving such a question. The question didn't specify any particular method to solve the algebraic, the quadratic, so we could use any method that suits us. So for this one, I'm going to be using the quadratic formula, and the quadratic formula states that x is equal to negative b plus minus square root b squared minus 4ac over 2a. Now if you can use the AC method to do this, feel free to do so. So now x is equal to negative 9 plus minus square root 9 squared, so always bracket, minus 4, 14, so x is equal to negative 9 plus minus square root, so this is 81 minus 56 so 81 minus 56, that's 25. So now when we get to this point, the aim is to get one of the solutions, we need to use the positive, and one we need to use the negative. Oh, and something here, we weren't solving for x, so let me actually change that quickly. In the quadratic, y is the variable, so we're solving for y. So for one of the solutions, y is equal to negative 9 plus 5 over 2. So that's negative 4 over 2. That's negative 2. The other solution, y is equal to negative 9 minus 5 over 2. That's negative 14 over 2, negative 7. So y is equal to negative 2 or y is equal to negative 7. So the solutions for y, so we need to find the solutions for x. X is equal to 5 plus y. So we can simply use that information to find what x is. So when y is equal to negative 2, x is equal to 5 plus negative 2, that's equal to 3. Similarly, when y is equal to negative 7, x is equal to 5 plus negative 7, x is equal to negative 2. So those would be your two solutions. Y is negative 2, and x is 3, y is negative 7, and x is negative 2. So I hope that is clear how we approach such a question. So the idea is trying to make the easiest variable the subject, and then we substitute that variable in the second equation, or whichever equation we did not modify. Alright, so let's take a look at the third question. This one says that the sum of the squares of 3 consecutive even numbers is 116. Form a quadratic equation using x, hence solve to find the numbers. So the sum of the squares of 3 consecutive even numbers. So we can start this off by saying, let the first even number be x, because they said we should form a quadratic equation using x. So we're assuming that the first even number is x. So that's even number, the first even number. So if we're looking at actual numbers, when counting, to get from one even number to the next, we would simply add 2. So if the first even number is x, the second even number is x plus 2. Then we would add 2 more to this. So the third even number is x plus 4. So there we have our 3 even numbers, x, x plus 2, x plus 4. Now it says the sum of the squares. Sum of the squares means that we need to actually square each of these even numbers, and sum means we're adding. So we're adding the squares of each of these even numbers, and that result is 116. Now it is expected of us to simplify, so let's go ahead and do that. So this would be x squared plus, now when we expand, x plus 2 all squared, that's same thing as x plus 2 times x plus 2, and you'd be expected to use the FOIL method to do this. Similarly over here, that's x plus 4, x plus 4, and that's equal to 116. So now that's x squared plus, so I'm going to be expanding this, so that's x squared plus 4x plus 4 plus, now over here expanding this would give us x squared plus 8x plus 16. All of that is equal to 116. So at this point we need to group our like terms and simplify. So we have an x squared here, we have an x squared here, and an x squared here. So that's 3x squared. We have an x term here, x term here. So that's 12x. And then we group the constants. We have 4 here, 16 here, 116. So 4 plus 16, 20. And then we would of course bring over the 116, and that's equal to 0. So therefore the equation that we're working with is 3x squared plus 12x minus, so this is 96, equal 0. So all we need to do now is solve this quadratic. So this would be the first part of the question, where we form the quadratic using x, and this would be our 3 marks. The next part would require us to solve to find the numbers. So let's go ahead and solve. So once again, we can use AC method, we can use quadratic formula, whichever way you want. It's up to you. So what I'm going to do is I'm going to simplify this by dividing throughout by 3. So I'm going to divide everything by 3. So that's x squared plus 4x minus 32. So applying the AC method to this, it would be x squared plus 8x minus 4x. So let's factor out x. Let's factor out negative 4. So x minus 4, x plus 8. So the numbers we're looking at would be x minus 4 is equal to 0. So in this case, x would be equal to 4, or x plus 8 equals 0. But in this case, what I want from you is the positive solutions. So for this type of question, we're going to be ignoring the negative solutions for now. We'll just be focusing on the positive solution. So we said that x is equal to 4. And look around here. Around here, we assume that x is the first even number. So if x is the first even number, and then we said x is equal to 4, that means the next even number following 4 would be 6, and the one after that would be 8. So we could conclude that, so therefore, the 3 even numbers are 4, 6, and 8. So this would be your 5 marks. We're going to be omitting the negative solutions. The negative solutions will still be correct, but we'll just be working with the positive solutions. So we can omit this. So this is a little bit less work for you. But if you wanted to get the solutions from this, you'd simply add 2 to this. So it will be negative 8, negative 6, and negative 4. And those would be your negative solutions. But for now, we're just focusing on the positives. So that's how we would approach a question such as this one. So let's look at the last question. So this last question here is a basic nonlinear simultaneous equations. And it says a pencil and an eraser cost $2.10. 3 pencils and 2 erasers cost $5.50. Write down 2 equations and hence find the cost of each item. So now we need to analyze this question to gather the important information from it. So it says a pencil, so that's 1. So 1 pencil, an eraser, so 1 pencil and 1 eraser cost $2.10. So the first thing we need to do is to assign variables. So we could say let P represent one pencil, and then let E represent one eraser. So P represents pencil, E represents eraser. So now this is what we have. So a pencil, and here is signifying addition. So a pencil, so that's 1p plus an eraser equals $2.10. And if you aren't comfortable using P and E, we could always switch these variables to x and y, something that you're used to. So let x represent the pencil and y represent the eraser. So x plus y equals $2.10. So now 3 pencils and 2 erasers cost $5.50. So that's the second equation. 3 pencils, so remember x represents the pencil, plus 2 erasers cost $5.50. So we need to write down 2 equations. So these would be your 2 equations. Hence, find the cost of each item. So if we're looking at these equations, we're going to be solving them simultaneously. And we can ignore the dollar sign for now. Just know that we're working with money. So the equations, x plus y equals $2.10. 3x plus 2y equals $5.50. So let's see how we can go ahead and solve this. So we can use method of elimination or method of substitution. However, seeing that we've been using substitution quite a lot, we'll be focusing on that. So this is equation 1 and equation 2. So for equation 1, and we know that method of substitution requires us to isolate one of the easy variables. So we could make x the subject for equation 1. So rearrange equation 1 to make x the subject. So equation 1 says x plus y is equal to 2.1. So x is equal to 2.1 minus, let's put it 0, minus y. So this would be your equation 3. Then the idea would be to substitute this into the equation we did not modify. So we're going to be substituting equation 3 into equation 2. So wherever we have x in equation 2, that's where we're going to be replacing with 2.10 minus y. So it's 3 open bracket 2.10 minus y plus 2y equals 5.50. Okay, so we replace the x that was right here with what we substitute, we transpose to get. So this is 6.30 minus 3y Alright, so the idea is to make y the subject from this. So we're going to be transposing the 6.30. So negative 3y plus 2y is equal to 5.50 minus 6.30. So this is negative 3 and positive 2. So this would be just be negative 1y is equal to negative 0.80. So after we subtract this, we get negative 0.80. So therefore, to get y, we divide by negative 1. So y is equal to 0.80. So remember, what did y represent? Y represented one eraser. So therefore, well, we're not ready for the therefore statement as yet. We can make a note to say one eraser is for 80 cents. So that's the cost of one eraser. So we know what y is. In order to find x, we simply substitute in this equation. X is equal to $2.10 minus y. And we just figured out that y is 80 cents, so let's do that. So x is equal to $2.10 minus y, which would have been 80 cents. So x is equal to $1.30. So therefore, so now we can put our therefore statements. So therefore, one pencil costs $1.30, and one eraser costs $0.80. And that's how we would approach this question. So I hope this video helped with getting a better understanding of these concepts. So I'll send the working out as well for your reference. All the best on the upcoming test.